Well, we'll let you know how long you have left for every presentations. 5 minutes after you all start, we'll let you know, and we'll also let you know 5 minutes and then 1 minute before the end. So please be respectful with the time you've been given. Right then, we're ready to start. We're going to let you know about how far we've gone. We've almost completed our objective, which was capturing the whole spectrum, the range of Wi-Fi and Bluetooth, although we had a little bit of trouble with the Bluetooth at the last minute. You'll see how. So we're just going to do the demo on Wi-Fi because of the Bluetooth problem we had. When we finish the Bluetooth code, we will upload it to the repository later today. Here we see the diagram. You see we have 4 ESP devices sniffing all the Wi-Fi traffic they can find and collecting it. The contents will then be sent to the reception probe, and from there to the server where the web interface and the database is. Why? Because we want to find any malicious agent anywhere. We don't want to generate intelligence or correlate data. Once the objective has been identified, that's it. Now, I'm going to connect onto the application panel because in the room we have now 4 devices distributed here in the room. They should be collecting information. This is the type of the device. We can see it up on the screen. They're connected through batteries. The application has this panel for access. It's all safe with logging and HTTPS with a signature. As we said at the beginning, we are using Django admin power for data management, editing, and so on. Basically, well, you can see like this better up on the screen. This is the basic Django interface, which is very simple to install. We use the token from the API to send the information with the devices. Then the application has these 4 areas. One is blacklist, where Macs that we detect as malicious will go. Then the devices collect the ESPs. Nodes would be the ESPs with the firmware images, and then the managers would be getting, well, we've used Telegram. We wanted to use SMSs, but the API was not coping with it very much. It was taking too long. Users with this application then, you see, this is the type of information that it collects. We have identified the nodes with a name, sending the MACs then, detecting what they are, the RSI, seeing if there's authentication, network authentication. If there was no control as to when devices can connect to send the data, there could be de-authentication and the information would not be transferred. So that's another value that's important to detect. I'm now going to show you a real-time detection, how it works. Here we see the working devices, except for the Bluetooth one, because we didn't have time to finish it. Now, receivers. There's Jorge and myself. We used the Telegram bot for our IDs to get the alerts. My device would be getting those. Right now, the blacklist is zeroed. Let's get one of the Macs that we have detected. This one, for instance. And we're going to add it so we can get the alert. Right, it's on the list now. Once packets get to the devices, those who have not been processed, those will be the last one to come, and then I should get the alert here on my Telegram. Right? 1 minute has elapsed, and the devices should be detecting it now. Right? The notification show it. So I'm going to leave this open for you to see the next alert. This is the type of message you get. Presence detected for the device, and then the probe that detected it. Numbers 3, 2, and 1. So that's short time detection. You see, it's coming again on number 4. The idea is that we would be using now the RSSI for the devices, knowing the range, the distance, and the time. With an algorithm, we could then geolocate that particular device, although we have to take into account the rebound effects and other values. That would be a detection of a blacklist device. The alerts will work whenever there is a detection, because I often think that when you have a light warning you about something in your car and you ignore it, then something will go badly wrong. So it's best not to deactivate alerts after a certain time. A module will be designed later so that it's not too invasive, so that if there are 15 different alerts, you don't get 15 messages, you would get it all together as one. So that would be MAC detection. What about a de-authentication alert? I don't know if you can see this up on the screen because of the letter type and size. We have launched our packets. It didn't detect it this time. On the side, that bar, thanks to Django filters, we can detect for every Mac, checking for de-authentication. You see, here it detected it. Oh, I know why it didn't work. I forgot AP needs to be set as the objective, the target. Otherwise, the alert will never come up. This time it should work for the next de-authentication. There you have it, you see. AP has been detected. Good. So, that would be the system. Jorge has been working more to integrate Bluetooth and Wi-Fi, and he can probably tell you better how that went. The Bluetooth chip was almost ready for our USSIs and so on. I must confess that I'm not very good with 32SP, with that particular multi functionality for multitasking. I had a problem for tasks not to overlap, and that was the main problem why we couldn't finally implement Bluetooth. We could see 8 max. That's as far as I could go, really. Unfortunately, you can't see how it would work. It would work exactly the same as for Wi-Fi, but for Bluetooth. Also, because of the different issues that have come up from other teams, well, first thing we checked when we started with the project is for it to support MFP. We checked the chips, mostly for the de-authentication side of things. Sometimes we don't know whether the support is working because of the chip, but we opened a ticket through Expressive, so hopefully with 5 gigahertz that will be improved in the future. So that's all from us. Thank you very much for inviting us to be here and for letting us take part.
Esta pásala en cuanto empiece y la de nosotros en cuanto acabe de decir nosotros. Vale, ya, ¿no? Vale. Hola, nosotros somos...
Good afternoon. Here are our names. Jose Ignacio, well, the 4 of us. And here we have the anti-shoulder surfing attack platform. What is our target for this tool? Well, warning a user that somebody else is there trying to see what they're doing with their device. Why is this tool any different? Because we want to defend the end user, which is the weakest link on the chain. We have 3 main objectives. One is for the application in the long term. The second one, we want to do well with the hackathon. And then, well, you will see what we have managed. So we want to develop a multi-platform application that can work on Windows, Linux, or Mac, so that when there is an attack and it's detected, it can then use different models of machine learning, both online and offline. Because we are taking part in the hackathon, we wanted to design an MVP, a simpler way to work with the application, so that you can use then later to also make the application grow. The hackathon asked us to use different models of machine learning. So we wanted to compare online and offline possibilities with pros and cons. We also want to find a subset of actions so they can be implemented on MVP. How far did we get? Well, facial detection is working, and for that we have used machine learning models that have been trained already. Why? Because of lack of time during the hackathon, and also because we can't access those models very easily. We've also done the multi-platform MVP. We have compared online and offline possibilities with pros and cons, and we have selected two offline models for the application with configurable actions that can be persistent. That is, even if the application is switched off, they're still selected. We also want the screen to be blocked when the attack is detected, and also for brightness to change and notifications to be sent. Let's compare the models. For the cloud option, we have checked RUS recognition by Amazon, and then offline two other models. The latency, obviously, it's a lot slower on the cloud. You first need to send your request to the cloud and be told if there is a face detection or not. Whereas offline, the machine does it all and it's much faster. The cost, the cloud service, you need to send your request, and Amazon's is quite expensive. So who's going to pay for that? Users? Well, there's no scalability there. Or we could offer the Amazon service with that infrastructure as a premium service for the application. But we were not convinced by that either. So we decided to use the offline models, which are free of charge. In the cloud mode, you always need the internet, Amazon, Azure, or Google, whatever. Whereas offline, you don't need the internet, you just need your device. For training, well, the cloud model has no training needed, whereas in the offline mode, you can either use pre-trained models or you have to train them yourself. About accuracy, well, the cloud model allows not just face detection, but also knowing if two faces are the same or not, and you only need two pictures for that with very high probability. About prediction accuracy, well, offline, it very much depends on which system you select. About user knowledge, well, the user needs to configure the Amazon account, whereas with the offline mode, it's all transparent and the user doesn't need to know what's going on. What are the drawbacks? Well, firstly, there are very few libraries for face recognition with machine learning, which are JS, because most applications are Python oriented. We used Face API .js, which is a very new library on beta with very few documentation, and that was a limitation because it doesn't allow for models to be offline. You need to first load on the internet. So first time you run the application, you should always use the internet mode. When developing the tool, we also found a security issue on Windows. When you run your application, it doesn't ask for authorization for the camera to work. It just starts recording, whereas on Mac, it does ask first time you use it for your authorization. What are good ideas for the future for this? Well, identifying the user. We didn't have time to include that, unfortunately, because the ISO is more complex than face recognition. The second idea would be using different cameras for depth and angle change, or to know if there's a camera behind recording. We also wanted to check when you move away from the computer for it to detect it and block it. Also plugins or whitelist for apps. So if you're using Sublime, it would know that that's the API and the device wouldn't work. And also shortcuts maybe in the future for the brightness to change just with a couple of clicks. And now my colleague is going to show you the demo. We've got the GitHub video of this demo if you want to watch it online, but we're going to play it live here. Let me just wait for the application to start first. There it is. Well, have a look at that top right hand corner. That's the application window. And we wanted to have that design without edges so to make it visually more attractive. We decided the window should be small so that it's not cumbersome, it doesn't take up screen too much, and you can move it just in case where it is by default. Imagine it's blocking something important. Let me just check. Oh, get a little bit closer to the camera. Well, it's recognizing my face. That's the blue framework. And down below, there is the confidence percentage that about my face. So there's face detection first. And here is the menu on the top bar. It's again not cumbersome so that it doesn't stop us from seeing what the camera is recording. Then we have the recording control. You see, I press the button and the recording stops. And my laptop says, the LED says that it stopped recording. And then you have this other button here for play and start recording again. Then on the right, we have the settings so that we can change the machine learning model we're using. Because developing the application, we have checked different models. Some have worked better than others, and the one we're using now is part of the repository, and it's loading now for face recognition. Why is this nice? Because in future, if we have a better model than this, all you would have to do is include that model's URL here, and our application would load that model. Here we have the different actions for our application. For instance, sending notifications if somebody is coming, approaching from the back, lowering the brightness as well of the screen so that people wouldn't be able to see it properly, or block the screen completely. My colleague is going to approach me now. Stand next to me. Oh, you didn't detect your face very fast. Can you just stay just a little bit longer, because sometimes the notification takes that little bit longer. Oh dear, it doesn't seem to work. Sometimes it takes a little bit too long. Let me go to the menu now. Let's check the brightness so that it detects a different face, different from mine. Then the brightness will be lower. I don't know if you can see that the brightness is much lower now. There is a keyboard command that we have included so that you can go back to the initial config of brightness, brightness in this case, and the rest of the methods as well. What about screen blocking? Ruth is going to approach me again. You see the screen blocks automatically as soon as it detects the other face. So that's about it. Logically, the demo video is available, as I said, for you on GitHub if you want to watch it again. So if you're happy with this project and you want to contribute, this is the repository on GitHub for you to do so. On tick next.
Que esté preparado CBNet, por favor.
The next team, CBNet, can you start getting ready? Good afternoon, everyone. The competition has been so exciting and so tiring and everything else, but here we are all happy to tell you about our work. We've developed a tool that can be used anywhere on the internet, but because we had very little time, we decided to just focus on some domains. Round about 6,500 domains. We've got a tool now then with a backend made up by the core that connects up to the websites and collects data for further analysis at the backend. We also have the plugins all structured in files, and then we also have a directory with configuration for each, or settings for each plugin. And then at the front end, we have the GUI for the user, where you can include the URL that you want to check and different options to choose from. Then we have a standalone area that we've called render, in charge of report writing in two different formats. And then we have a browser, Selenium, that can be automated, which is what we use for while browsing the websites. Because it's a local demo, I've got it here on my computer, on my laptop, but we want this to be a tool that will be scaled up in different modules so that we can have N front ends sending requests, launching to N cores, each core with N instances of Selenium, so that the system capacity could be greater. We've used Selenium connections as well, so we don't have to design too many of them. And also, its cache means that when two requests are sent and you're not sent a reply, then the last one will be valid. What's the idea for plugins? The input is an object in Cascade, just in case information has to be shared. Then the output for this would be its name. At the output, we would have the name and the score as a percentage, seeing if that truly scores or not, and also if the plugins have to be stopped, and then an area for messages for human interpretation. What plugins have we implemented? Well, a dummy, which is a little bit like a framework in case you want to develop it further. We have two automatic plugins, the SSL and the online confidence one, to check if the SSL is present or not, if it's still valid or not, and also the confidence one, if it's present or not. And nobody needs to intervene. What about the plugins for cookies? Well, those work semi-automatically, recovering the cookies first, and then there should be a blacklist and a whitelist to know if they're harmless or not, if there's some infringement or not, although that is a manual process to feed all of this. We should also feed other plugins that have definitions for legal laws and regulations. For the SSL one, apart from finding the URLs, is also going to be checking for contents within each URL. And we called this plugin definitions because it can't be automated, and this is a tool that has to be fed a little bit like updating the database for definitions in this case, like very much like an antivirus would work or works. Let's have a look at the interface for the website. We've prepared these screenshots but we can actually launch them later if there's time. So here, the URL, the domain, we press scan, and this is the result. This is 0%, so that wouldn't score for the total at the end. Then for other ones, we've got different percentages. Here it tells us which cookies are allowed or not, with prorated percentages and a final score. If I press here on ODT or PDF, well, the report would come up in whatever format in a more visual manner. This website doesn't have online confidence. The score is 0. It doesn't count, so it's in orange. In red, whatever seems to be problematic. In green, whatever seems to be fine. This scroll down menu allows us to choose which plugins we want to run. In this case, we have not marked SSL confidence, for instance, so that it can skip whatever we don't need for the reports. This is another example with a different website. And this is an example that we prepared specifically to make sure 100% would be scored. You see, there it is. What about the backend? Well, it allows for statistics to be there, statistics that have been stored. It looks a little bit prettier like this. Here we have some examples that we've prepared. What can we do here? Well, send it to Graphena, or because it said JSON. Then we can continue to feed the statistics for the different processes that we cover. There's also an individual service for each and every analysis in JSON. In case you want to integrate with URIs, well, we've got this other prettier display. It gives you information about time, about the different details. You see, you could access this and then work automatically. What about the proof of concept? We've prepared an add-on for Firefox to be able to connect up to the service and do the reports. So when we visit a URL, how do you know? Well, this is the URIs icon with the percentage. You see, 25% for this website, that's red. This one, 87%, it appears as amber, and green for this one because the total score is 100%. So as you browse and visit different websites, UDIS tells you how much you should trust that particular website. Now, for the website where the score was 100%, this is the report. It would be great to continue to develop this tool, which is a bit of a shame when you do something like this at a competition like a hackathon. You might come up with an interesting project like this, and who knows, some organization in CIBE, for instance, might be keen on helping this go further. Because imagine, if the system gives you a 100% score, in that case, the system could offer you like a quality label that your website could display, just to tell surfers that you comply with the URI's requirements. I think that's about it. So that's all from us. Thank you very much for your attention, and all the best for the rest of the teams. Well, because you have just over a minute left, can I ask you a question? Could you show us internally how the plugins work? how they check detection for the final score to be calculated. I mentioned earlier that there's this area here for config with settings. For instance, for cookies, that's a manual process. It has to be at the moment. I mean, it could be then that in the future there might be something like an antivirus where updates are automated. And then the plugins are here. They're independent. Let's have a look at the LSSI one. We get the driver, that is the instance we send to Selenium, then comes back for that website. That's processed to find links that are defined in the config file. In this case, we've got these three. So when it visits those three, it then searches for keywords. We have included those here. That's the number of the particular law, the trade registration, those formal details. And if those criteria are complied with, that's when the 100% score is calculated. Well, and this is where the message is worded for the final report. And here are the functions. One, processing on the basis of the different links I showed you at the beginning, and the other one, loading the configuration. Great. Thank you very much for that. It's CBNet, the next team. No, sorry, that was CBNet. The next team, the Tigers.
Bueno, os vamos a un poco presentar rápidamente el.
Let's start then with a presentation of this demo and showing you how far we've got. Our main objectives for this project were security, because it's resource intensive. We need a lot of memory, a lot of CPU resources, and in order to improve that, we want to focus on performance and on a distributed solution in different layers and with feedback, so that we can have a network device with a layer. How far did we get? Well, for mod security, we have managed to communicate so that if an attack takes place and it's identified, that will be like an HTTP request without a host. And if that condition is met, the system finds the client's IP, and that is fed into the system. On NFTB, we have this property with whitelists and blacklists, and also traffic limitation to have the threshold for each origin IP. We've also got functional tests to then see if the protection is actually working. During the tests, we have checked the scripts. We have created the scripts, sorry, for pen testing and verification. And to see the efficiency, and we have managed to have a tool that behaves in a distributed manner, as if different users were connected at the same time. We've also tried to use new libraries. We'll see which ones later on. The extraction went fast. Here we can see libnml, libnft, and libnft tables. Those were the libraries that we've used. We have compiled the load balancer for NFTB, and we've also worked at the backend. These are the new parameters that we've added to the API. We've identified them, we've added the values, and the demo will later show which ones they are and how they work. We have used different objects, get and post, and we've identified them. What problems did we encounter? We have used technologies that are still under development. Why? Because we want to help the community use some of the new libraries. We've also communicated from WAF to the API. We have managed to have an SSH tunnel so that information can go more securely. We have also found new proposals for attacks for DOS. Later we will see how, although that was not our main objective. We don't want to have a seventh layer objective, but anyhow, we had a little bit of time and we tried to improve that side of things as well. As my colleague was saying, what we found about evil reaches is that mod security has two parameters for configuration. One that limits the maximum size for the file, so we can either process that amount or reject it. We have also managed to define the maximum number of matches that can be found with a generic expression. And then on Apache 2, we've got keep alive timeout. That means we don't allow for connections that are over the timeout time. So if an attacker wants to send very large HTTP requests, the system will stop that. Now, what about future developments? For the future, we want to migrate the solution to SSH, supported by HTTPS. We want to generate the API key, which is more robust, and also the hardening of the load software. We're just going to quickly show you the demo, just for you to get an idea how it works. Just 4 slides. Here we have the client side, where we simulate connections to those two IPs, connecting onto one, which so far only got the packets and distributed them equitatively between the two different arms. I'm going to show you one of the attacks that we managed to stop, the Flux one, and then another attack to send a get protection that will be identified as malicious at the server side, and that will inform the load balancer for the request to be included within the blacklist. So let's go for it. So don't worry that we can't see the big screen. We've got the smaller screens on the side. So forget about the larger side not having a big enough letter type.
Bueno, en la parte superior tenéis dos clientes que son los...
So on the top side, you have the clients getting the connections, and then the bottom side that I cannot see because I will focus on the top side of it so that I can extend it.
Ok. Vale, pues bueno, os dejo aquí puesto uno de los servidores.
So this is one of the servers you've got here. So here you have the load balancer. I have the setup ready. I'm showing this to you. I'm sharing it with you. Here you have the current configuration on JSON. We have a virtual server, and default we have a 500 limit, and the bus limit is 5. Then on the other hand, this is our web client, which sends connections concurrently at 50. So here you have this short clip, and you will see how 50 connections are spread with other servers. See the server going up? We will get some 50 connections on either side. This is my system where I identified that there is a DOS attack. Here is my IP ready, the API that is, and it will move over 500. That's the value I've loaded, and I set it at 5. I call the device. And you see the value load means that this is decreasing. So we change connections, and so we see that this value will be at 5. And we've realized that the value was 60 concurrent connections, and here we stop at 5. This is the 60-second time that is about to expire. This is the first DOS, and the worker states that we've changed X connections in within those 60 seconds. This would protect us from DOS attacks. And then this other attack. So this is the blacklist that I'm loading. Same as before, but this is a blacklist, so the backends can check it. Here. I just got this request here. And if I try next time, NFT list, and right now this is a blacklist. Here I am. 5780. The device is there, so I cannot get on until 10 seconds from now. That is the predefined value. And now that I got the blacklist, I can use the system and gain access to the system. And that's all. So if we stick to time, is that an extra point? Well, I think about that. You need to know that I'm having a terrible time here, but I'm forced to controlling time. Sorry about that. Tigers, 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 lions, lions, lions. I'm an old-fashioned guy. Next one, get ready. Fish and chips. Fish and chips, are you ready? Then fish and chips. Force majeure reason. It's health reasons, so we move on to the next group.
¿Cuánto tiempo habíamos dicho? ¿5? ¿4? ¿5? Vale, ve para allá. Vale. Buenas a todos.
Good afternoon, everyone. We're Fish and Chips. We've developed fast fish for phishing detection, large scale. As the competition started, we said we would be working on these items: minimum domain collection, minimum structure. You cannot find phishing unless you find new domains. Also, analysis of structure. You need to, structure analysis, because you need to look into the data. There's no point in mining data when you don't make the most of them. And then on-demand request, you need to have the data, but someone needs to check them, or at least check them in an accessible way. And we will also have a database integration. We're interested in persistence, finding if it's 15 seconds and the program stops, and this is a 24/7, and then basic module compatibility, so people can add their prioritized solutions or contribute to it in any way. We think we've nailed it, but we have a minimum collection structure. Basically, it's web parsing or certificate parsing, also minimum structure analysis. We follow something like Hamming distance, also minimum on-demand request structure. We have two APIs exposed. One is HTTP for common users, and then one on gRPC for high performance, minimum integration with databases. Here, using Redis because it's easier, because it's widely tested, and only rarely it will cause trouble. And module communication with it, we said it is gRPC and protocol buffer, so that it's agnostic. If you want a module on Python or Java or whatever, you can, as long as protocol buffers has a compiler for the language, and the protocol buffers that we distribute are used, our program will get the message. We've also added some more things that we did not introduce at first, such as TLS communication. This is a cybersecurity competition, so it would be pointless to have an unsecure communication tool. We use TLS for both sides, module communication and client communication, both. Modules internally need TLS in case you host the tool on Google Cloud or AWS or Azure, so no one can read it. And then client communication, or communication between client and server, needs to be closed as well. We've also added add-on JSON modules. Could be any other format, but we've chosen JSON because it's simpler. Number of cells, sources for certificate transparency, also diffuse logic to see whether it is anything like it, and some collectors. Here, the certificate transparency is generic, so if it matches RFCC, we can use it. Then we also have a website with the data sets of the domains recorded today, the day before today, and a few more days before today, or just by reading a file that you can parse or a generic interface. Technologies we've used, gRPC and protocol buffers for communication is agnostic, also go for this purpose because we like it. It's simple and concurrency is cheaper than other languages, and that it is multi-platform and ready for the database because it's simpler. Next, we'll try to run a live demo. It'll be my colleague doing so. As my colleague said, every connection is TLS protected. We have some certificates as part of the project. Naturally, these are signed without a valid key, but it works for the demo. Here we have the binary that is used for the file. We'll be using that later. And we also have the setup, the configs that we discussed, our colleague discussed. And as I was saying, we have Redis as a database. And let me show you what it has now. There are a few domains already uploaded. First, we'll start the database module. It's all modular. We said that those are different binary codes, and we could start that on different servers, different computers, same one, doesn't matter. We've already got the config there. We got the API ready, which would be the access point for any user or outside software. And the first demo I'll run is one of the APIs that we've implemented through HTTP on Cur. It's open and connected to the API. And we also have the module to be analyzed that is using this algorithm similar to Hammond's. And we can use it for domain analysis. We send the curl request. We check whether it's Twitter or Twitter-like and see if this is phishing. We send it and it says it's probably phishing. It's a 90% confidence interval, and it's been received by the analyzer. We've checked the accounts domains that we've set up and see what domains we want to look for. For example, if we're a company, we can set our domain to look phishing against our company. And you say this is phishing against Twitter. For all others, the score is way too low. And here, everything has gone through HTTP, as we've done before, looked into it, gone through the API because it was a user. And then if we go back to Redis, it's been stored into the database. See that the score is there? If I send it again, nothing's changed. It will not waste any time on analyzing it. It just got the score that we had already saved. If we send a request to a valid domain, it'll say this isn't phishing because Twitter is the valid domain. We also have a client with the API, for example, an email scanning software, something of the kind, and we send it. there is this battery that we've programmed ourselves, but this is just for the demo. We would not use it. This is Twitter. We've seen it. It just got the score from our database. Everything else, Facebook.com or FB.com, has been locked into. Same here. Same here. If we do it again, this is not analyzed, it's on the database, so no need to go through it. These were all on-demand requests. This is also a collection module. Let me show the certificate transparency to you. And I'll cut it off because it's running on my mobile Wi-Fi. So just a few seconds and stop it. And you get all the domains, compared them against those where we wanted to check whether they were phishing or not. We were unlucky here because they weren't phishing. They've all been through here. Actually, the repeats, it didn't analyze them again. They are on the database. And see that they've all been checked. Well, we've met every goal here. So we just need to have more analyzers, but we have an interface that can be used for any language, so it would be negligible. More collectors, same, we have the certificate transparency. So database, files, easy to implement, more APIs. We've seen just two, gRPC and HTTP. We can also implement some kind of a cache that is halfway implemented, but we need to have one that is more efficient. A deeper configuration, because we have one. As my colleague explained, we can set some variables, but we would need to set some of the ports to start services, and also an automatic deploy if we wanted to use it at home as well.
Nada, pues perfecto. Adelante. Tigres va ahora y luego...
Next, tigers and then cell.
Vale. Vale, buenos días, somos el equipo Tigres.
We are tigers, and our product is Error Hit. In case you don't remember, it's an improvement on AirCrack. Sylvia, Rule, Elena, and myself, Ricardo. We were starting from scratch. We had not written any code, so we had to make some changes. For example, data capture. From the suggestions we got, we've been using AirCrack. That's the name of the project, the name we were taken after. And then these are the tool, this is well known on Wi-Fi. And then we had so many problems with the graph libraries for JavaScript for the heat maps, because we had the idea that we would use a leaflet, but then we ended up using Google Maps. And I'll explain in a minute. We had some trouble with the server. For Python, so data capture, it has two entry points where we change what we've captured second by second on GPS on a CSV file. That's the one that we treat and process and move into the database, and then we have Kishmit's official output. Even though it's way more reduced, we can use it for heat maps with our tool and see all the tables with everything having to do with that. Because, well, actually, we wanted to go further and keep information on clients and all second by second for client monitoring or projects a bit more focused on clients, which you cannot have with Kismet. So as I was saying, it is a Kismet-based capture, so we didn't have to touch it, just a Python script. So it reads the file and goes into a database, and then the aircraft change on written in C. And we added two outputs, one for IP, another one for client, which is a CSV with the GPS position every time is found. So these are two Python scripts that read the files and save them to the database. The database, do you have it? So this one here, that's a database. We have the IP and the client tables and the relationship in between, which is connections, and then the probes in every client. And then the APs and the clients whenever seen. So this database is not complete one. We have not filled every field. And that's one of the to-do items. But what we are most interested in for this project, for this stage, it's all in here. So these are SQL queries, quite simple, that help us recover information. Once we have what roles done, that is database production, we can produce several results, which is most visual, and that's what the client will see. For the web app, we've used a node server. We were using a backend on C#, but we were in trouble because we were not familiar with it, and so we moved to Node, which seemed simple and yielded us better results and faster results. Apart from JavaScript, it says JavaScript frameworks. Well, it's actually CSS frameworks with use admin and Bootstrap. And then the graphic libraries to show the results for the interface and the result display. Let me play the demo for you. As you can see, there's an interface. On the left side, you can choose access point information collected, client information collected, or heat map generation. So if you move here, you can see and choose the name of the network that we're auditing. Let's say this is a pen tester's view with a Wi-Fi audit. When we click here, we see data. At first, we only had RSSI, and so we were suggested to set the average, the maximum, the minimum that we see here, and same time. But from how we've done it with the name, we can also use the MAC address in case we were looking for information for a specific access point. And just like this, now we only have these few results, but we could add a few more. Same way, sure. Same way, we can find all the information we can gather from clients. We choose clients. This is the first one. But as you can see, in the traffic capture we had, the database produced has many different types of networks. This is CyberCamps, and there you see that's the routed MAC address used, the client ID, and the type. This is all Wi-Fi because, well, as you will see with the to-dos, we could not include the Bluetooth here. You will also have the heat map generation. And we've been using Google Maps, as we said, mainly because it was a suggestion, and also because we had some problems with lift left that we had chosen. Here,
Just in case it doesn't work, we prepared a video.
Os pongo el vídeo y así vamos un poco más rápido.
Well, just because of time constraints, we're going to play the video instead. The name of the network, in this case CyberCamp. And now we can see what Raul has done. He's the one who was in charge of the capture. We didn't have time for the legend, but look at those areas in red, which is where the RSSI value is higher, where the route was in the building or around it. Well, you can see it in a very visual manner. You can have different modes, satellite mode or street view. You see, this is our building, our venue for CyberCamp. So, in the past, we were selecting tables for the different names or the MAC address. So, if we look for information of a particular router, look at that. That corner there, it says that's the router we're looking for. So, if in a particular organization all the routers are the same brand, and in our inventory we see that in a MAC address the bytes look different at the beginning, then we can find it. So that's about it for the interface. What else would we like to do? Well, Raul said it, the database could have more fields so that we could have more details about the maps. We didn't have time to include the legend, having the different paths for the dots, but we did do it for the other library leaflets. Let me just quickly show you. You see? The different points that Raul covered, where the samples were taken, and we have the coordinates and the RSSI value. That could be added to Google Maps. And last but not least, we still need to add the Bluetooth module. So that's all from us. We want to thank you for your attention, and we'll be happy to answer any questions you may have. Just as a reminder, we will have a general Q&A session for all the teams, and that's why we're first listening to the presentations. No questions. We did leave time for just one question in the case of the one team that still had time to spare. Presentation time, that is. Can we now hear from Ubanoops?
No lo sé, está mal. Sí, pero si lo curioso ha sido el primero en probarlo esta mañana.
It's really annoying because it worked beautifully this morning. I was the first one to test it, and it worked just fine. Now it works. Don't touch anything. Good afternoon, everyone. This is the name of our team, Zell, Alvaro, Ivan, and myself. We are together. We're studying at university, and we find that sometimes universities have certain rules, and just to improve the situation, we have developed Stock. This is a tool to provide safety to a system's admins and to users. In this case, it could be a facility at university, maybe a laboratory. We want the system's admin has the safety that ports won't be open by default, but rather for them to open as needed through port knocking mechanism. And also users, students in this case, having factors for double authentication. We've prepared a demo for you. Here we have a user's registration screen. You see? Let's say, yes, Ivan, my name. That would be the screen for registration. We then activate the double authentication for the QR code, or rather the OTP key to be activated for that particular student. We scan the QR code, and it's a shame you can't see my mobile phone now, but it shows me a code that refreshes regularly for us to verify. And I'm the only one who can verify that on the application because it's my mobile phone. That's where I have this code. I keep getting these codes. So let me access with an admin user. Admin of the platform, that is. Right. This is the user that is going to let us access whichever machine. My login was Ivan G. And that's how I let the machine that I selected earlier be accessed. Now I log out my admin, and then I log in with a normal user. It then asks me again to identify myself. Right, that's the login done. And see how I can now access the machine that I selected as systems admin. So I then download here a client for that machine, and I then download the profile for that machine. This is the profile with user details, which then connect up with the supervisor's information so that through SSH or whichever other service I can then access the machine. So let's see how this works. How the port knocking the request works. This administration portal doesn't actually handle the machines. It just has information on users, the mapping. So the infrastructure admin would be in charge of all the rest on demand. So I've got the template, which I downloaded, and here I can run stock, which is the name for the administration. What's the code right now at this time? Right, I've typed in the codes, and this is at the top the supervisor who gets the packets given by the firewall. So it can then identify the port knocking sequence and get the token then with details on the public password and the username. And this is the response. It tells me that the code has been refreshed. Which is the new one? 670. Right. Has it expired again? Well, apologies. We need to be fast here, man. Well, this just shows how it's not easy pretending to be somebody else. You need to be fast with those codes that are refreshed all the time. So the supervisor doesn't act on itself, but on the machines that want to be accessed. Through firewall rules, the window opens, and then jointly it administrates the public keys so that access can be granted without the need for a password. So all of this, the settings can be changed. We can also use a NIC to access the machine. For instance, I'm going to now access through SSH. I should have access here. Let me just go back to the presentation a moment. Let's see if it lets me show you the presentation up on the screen. Now, these are the technologies that we've used: Ruby and Python. Python mostly for the client's grapper. And then connections are done through sockets, not with SCAPI, or we didn't think that would be correct or even feasible. And then what about the supervisor level? We did use SCAPI there for interpretation, and then Ruby mostly for authentication. To work with the users to check that the key is correct. So all of that works on HTTPS. So the supervisor there would be checking if the key is correct. The key that's generated regularly. All of that has been done just with virtual machines. We wanted to make it nice and simple. So this is the more detailed explanation of the sequence, how it works. It tends to work on different ports from firewall that forwards to the supervisor the packets so they can be identified as port knocking. Once that is identified, then the side gate is open for the token to be sent, logically encrypted and with a certain integrity, so that the supervisor can then work with administration of those keys, well, after a certain time. Because this is a hackathon, we wanted to analyze vulnerabilities. And there's one main vulnerability here. It would be the authentication server. That's the only element that users can access directly, so that would be the main target for T2 attacks. Our system is not compromised because you can't access the machines. The authentication server, when it crashes, it can't identify if the keys are correct, so you wouldn't be able to log in. The rest of the infrastructure is protected, as I said, because the user doesn't have access to machines, because the ports are not open, and because the machines delegate all the traffic. So, what about possible future improvements? We would have to double-check details. And members of the jury mentioned that some details should be improved, but we will also would like to have a new authentication system. For instance, the FIDO key, I believe he said. We have implemented the key, but for the moment only for the client application that connects up to the machines. We should still work on that, but at the supervisor's level. What else can we say? Well, we've had such a good time. It's been a wonderful experience being here for these few days. Thank you very much to all of you.
Ahora va Ubanoops y sigue.
We'll now continue with Ubanoops, and the following team would be Security Bag.
F5.
No sabemos cómo se ve.
Bueno, somos Blue One-Ups. Hemos hecho.
Right, our team has developed the blue fingerprint application. Well, we haven't quite finished. We only got halfway through. We have been using the HC06 module that we can see up on the screen. So what are the different stages of the communication that we've been developing? Our project was actually more complex than we originally thought. That's what we found. That's been the first conclusion. The idea is that a message is sent from the mobile phone, from the Arduino to the Arduino, with a flat username. If everything works, the request gets there, and if it's been saved, and then a challenge will take place. Then a deciphered number or decoded number +1 would go one way, and Arduino would then send a message as well that we have verified with a LED, an LED. There are different modes for opening and closing, but unfortunately we had no time to finish that. We've prepared a video for a use case. This is the list of devices. You can see how it stops blinking. I then say I'm a master. We then get a challenge. We then send the following one +1, and that's when the light comes on. So the next case is pretending I'm an intruder. I sent a different chain that hadn't been saved. That means it's not a valid user, and as a result, we are denied access. The white LED means the request is being generated. So we didn't have time to cover this stage, this new step. You press the open button, there's a new session started. There's the exchange between both ends, and just to check they have it, a new number, random number, should be generated and encrypted, and the packet would be encoded and decoded to check it's there. Only the master could do this. This has to do with a user list. Arduino would send one by one messages with users until it finishes the file or the process. And then the master device would then send the message for delete whichever number of user out of the ones you sent me. And then the last step would be from Arduino to the master, a message for OK or not OK. The add USB would work similarly. From the master, the string would go to the Arduino, and then depending whether the information is there or not, or if the addition was correct or not, the message would go back as OK. The initialization of communication has a protocol that includes Bluetooth communication, which is very well covered. Then there's a database that's managed through Bluetooth. And because Arduino works at a very low level, well, we found that really complex and we didn't have time to implement it. User ID is correct, it's working okay. And the mobile phone and the Arduino have been communicating fine. We found a way to process information both at the mobile end and the Arduino end. Let's not forget that they work with different types of data. It's always streams of characters for communication. And then we still have to work with the files for passwords and so on. We have no time for that. Unfortunately, we couldn't find compatible libraries at the mobile phone end, and we still need to find an algorithm that works well with this project. Also, for multi-user use of this application, we still need to work more on it. Our main problem has been having a very short time, and also maybe the encrypting. We should have been faster with that. Just an idea for the future would be having a time key. Imagine at the moment you need to stand close to the Arduino, whereas in the future it would be nice having different users with keys so they can access without having to be close to the Arduino, when a user is logs in. Yeah, we were thinking about how sometimes you might otherwise have to lend your key to somebody for them to use the system first. And then you would need to have master signature to verify ID. Maybe we can run the demo of the different stages. Right, let's do it.
La primera fase de la seguridad corresponde a la identificación del usuario, que el usuario.
Now, for user ID, that has to be registered on the Arduino database. That's the first one, the first step. And if that doesn't work, if it's not correct, as is the case now, what happens? If an unregistered user tried to connect up to the Arduino, from the very beginning, Arduino would reject the service and connection would be restarted. But let's imagine something went wrong and communication continued onto any of the following stages. The user has been detected as valid in this case, and there is a correct challenge response, and that logically includes the encrypting. So let's imagine I know of a username that I can then cheat the system and pretend I'm that user, registered user. Well, it let me go through the first level. There's a proposal for a challenge, but that's encrypted, so I won't be able to respond to it correctly. So there would be denial of service, and the system would restart. So that's all from us. Thank you very much for your attention.
Una pregunta por...
Can I just ask you a question, just to make sure I understand about the encrypting? Is there encrypting or not? Because you were talking about challenge and response. Is that not encrypted? Is it just a challenge and response situation? Any message coming from the mobile phone, except for the first ID message, is encrypted with AES-256 or whichever one we implement eventually, because we haven't done it yet. And for Arduino, encrypting works because we have used a predefined library. But because Javi works with Java, that doesn't allow for bytes, and we were a little bit limited there. We still need to work on the encrypting more. But confirmation messages from Arduino, as in OK or not OK, that goes flat so that it can't be discovered.
Siguiente será IoT Vigilant. Ahora...
Let's continue with IoT Vigilant with their security bag. Let's continue with IoT Vigilant with their security bag.
¿Se oye? Sí. ¿Esto también? Sí. A ver, porque esto está un poco inestable, perdón. Ok. Voy a poner esto a lo mejor. ¿Qué tal, qué tal, qué tal? Buenas tardes. Veo con una paliza que no veas, ya os lo comento.
Right, let's get started. Let me tell you that, remind you that we all have secrets, right? We all do. For instance, an API key, a password, a PIN code, access for details for a credit card, whatever information we want to protect for whatever reason. But starting today, I can tell you that we are all going to have secrets, fine, but we will all have somewhere safe to keep them. This is it, guarded books. Logo that has been generated from a random system that we found on the internet. So what is Guarded Box? It's an online application with a server. It's up on the cloud, and so that we can store our secrets and then access them anywhere, anytime, from any device, and use them. Because secrets are going to be encrypted at the server, encrypted at the user's device, and with a key that comes directly from their password. So secrets will never use your device, and at the same time they will be protected. We can then share secrets with other users using an cryptographic system, which is useful if you ever want to send me your bank card details. And we think the main feature here is that it's been implemented following the most stringent security practices and guidelines, and with a mechanism to guarantee that password and the key to encrypt and decrypt our messages is nowhere in particular, just in your own head, which makes it a lot safer. This is an open source application on GitHub, so that you don't just need to trust me. You can see how it does what, and all of this in a container, so that any company can then download it and deploy it.
Las instrucciones para
So you have all the instructions to deploy it, or if you don't feel like deploying it and you just want to use it, you have it on the cloud, in the cloud, and you can use it anytime you want and free of cost. You just go to guardedrocks.com. Wanna see it? So volunteer up here, because I need someone else. So I don't know what it is. Well, I cannot fit it in there.
Sí, está duplicado, ¿no? Yo estoy aquí haciendo el tonto, el mongolo. Vale, perdonadme. Vale, eso por ahí. Y eso por ahí, ok. Bueno, ¿conocéis Mailinator?
Do you know Mailinator? It gives you mails. So build one with the name, whatever you choose. Just choose a name. All right. So the other tab, well, maybe you've chosen an address with lots of crap, because anyone can use it. So you better use a different one, because a longer one. So this is the other tab here. Please use your new email. So at mailinator.com, as if it were your normal one. Mailinator.com. So CAPTCHA, this is the security one. Google, please. Now is not the time. So it says you will get an email with instructions to sign up. So you use your email now. I'm sorry about that. You should get an email. So click it and you have a token on the URL. You can see that. And let me just tell you, okay, use a password, not a usual one, any other password. It has to be longer. There it measures the length of the password. So click on the eye down there. There you can see there's a length and entropy measure. If you choose something like that, you will not be able to register to sign up. It has to be a bit more solid or robust. So as you can see, you need something that is longer, 20 characters. Wow. 20, so, okay, hit it. So, capital letters, small letters. You can copy it if you wish. You can copy paste it if you wish. Bit longer. Okay, you can have that one. Copy it for later and just fill it in anyway. So choose longer things, but all right. So sign up. Now it's producing a cryptographic key that depends on the password, and the other one depends on the question. So you're signed up now. So click anywhere, and you will go into login and say remember yes, or else you type it. Not difficult, but just in case. Okay, get code. Because we have a second authentication factor that will be emailed to you. Right now, same cryptographic key as before. So we'll be using it. So email next. Okay, see if you have it. All right. So a secret, anything you want. Doesn't matter. It'll measure the length, and that's not compulsory. You just need to see whether the secret you're adding it's got the strength that is needed or not. And that's your secret. So if you press reload, you get it from so reload, and you get it from the database. So this is coming from the database, and this is encrypted. You need to press decrypt. So the one under value. There you have it. Leave it there and you copy. Then on the right side, that's my cell phone. That's my account. So move the window away so that you can see. So there you have it. On the right side, you see my cell phone. These are my secrets. And so I'll move to the secrets share with me. And there you see Rule wanted to share a cross-site scripting. Thank you very much for your audit, by the way. And share the secret that you've just produced with my account. You have it there. You can share. And type my email, which is Juanjo, Toga, Torres Garcia, that's what it stands for, 89 at hotmail.com. I got it here. Hello. You've shared with me. That's a secret. Thank you very much. I'll finish in a minute. So what's this? The development, the deployment on in the cloud. So this is a self-scalable container. I don't have much money, so if you add lots of things, maybe it's easily scalable. But so far, the free version is more than enough. What have we not done? The password recovery. Didn't have time. It has all been planned in the database, so we have the responses to security questions and everything else is all ready, but I could not have that. And what else has been done? We had a crypto challenge login, which adds a good deal of security because they that never gets the password, and also the keyword entropy expansion. Thank you very much, and some future plans for the future. And thank you very much.
Vale. IoT Vigilant y a continuación eSecurity.
¿Se ve algo ahí? ¿Así, no?
Para los equipos que quedan, es conveniente que no pongáis la pantalla en extendido.
So please do not get the extended display because you will need to use the main screen and you will see nothing. Use your laptop and we will use all other screens. We're ready. We are IoT vigilant. And before we start, let me thank the organizing committee for inviting us with this idea that we came up with and thought would be interesting. And we had so much fun developing it, even though we're tired. But as you can all imagine, IoT Vigilant is a project we conducted with the idea of modeling behaviors in devices with a low interaction, such as IoT devices. And because of the massive increase for these devices, and I think we're all aware of the dangers they entail, we would like to offer some kind of aid to improve security of those devices. So the idea would be to monitor those devices on the network, on the internet, see if there is any kind of weird behavior with the device that we're monitoring, and there we would get an alert. So the architecture we thought of for this is several IoT devices on the same router. This would be a Raspberry Pi. The Raspberry Pi is connected to the internet and then connected to a server on which it sends metadata we thought were most interesting from all the packets captured from the IoT devices. Then these data, we keep them on an Elasticsearch, for which we have an algorithm with behavior modeling. The idea is to find these weird behaviors, report the database, the Elasticsearch database, and then show a nice view to the user of how good or bad the shape, in what good or bad shape the network is. We've thought there are several technologies that can be used to capture metadata from the packages seen by the router. And so we decided to use SCAPI, so that any device that can run Python can run our program, our sniffer. And thanks to the viewer's suggestion, we decided to conduct a short proof of concept that maybe is a bit more widespread, and it could help us if we see that it is useful. And helps us keep developing it, which we would very much like. These sniffers just send data to the server, and we see if there is any kind of weird behavior with the devices. We've already discussed this information back to the server, and the local server can have an API REST waiting on the SCAPI to get all the metadata from the packets detected and then kept them on Elasticsearch, or maybe the server has a NetFlow server waiting on them to embed them on Elasticsearch. In any case, regardless of whether we're using NetFlow or SCAPI for this Elasticsearch, we always get the same data and the same structure. Anomaly detector, thanks to the Euro's help as well. It uses a Gaussian algorithm, and Victor will explain what that means. And since I'm running out of time, let's start the demo. So, first demo. We have several Docker files to show you first the infrastructures using SCAPI and NetFlow, with the idea of seeing that they do work. And then we'll have a bit more specialized demo where we'll see the full behavior of the system. So here, we get the Raspberry Pi to send packets in NetFlow format to my server. And the Raspberry Pi will get all the packets from all the devices connected and will send the NetFlow format packets to my server. On my server, which is a Docker Compose that we will get live using just this. So we will use a Grafana, the server for the NetFlow data that will be saved in Elasticsearch. We don't have time, but believe me, it does what I do. It does, and all three containers are on. And then next, on to the next test. Same test is just the same. We will use Grafana, Elasticsearch, and the host waiting for the data. But here, as inside the Raspberry, we'll be running SCAPE. For that to happen, so we need to go to the Raspberry and run the sniffer with the IP, the port, how often, the interface it needs to check, and we can also have MAC filtering so that we can decide what we are interested in looking and what we are not so interested in looking into. And inside the server, or my machine, just to go live, let's use a compose again. Quite fast, by the way. And here we have an Elasticsearch, Grafana, and a web server that allows to acquire all those data from SCAPE and keep them on Elasticsearch. So you could see how we are saving this insight, but we are actually short of time, and we still need to discuss what's most interesting here. So great. And finally, let's discuss a full deployment, which does work, by the way. And for that, all we have to do is inside the Raspberry, we run the same command as before, but here we've added cert and protocol HTTP5 so that it's locked using HTTPS. We've used a self-signed certificate because for our demo, we would not do anything more professional than that, but we wanted to show that we can do this the safest way, at least encrypting traffic. So I have it here, and you can see every number indicates metadata from a packet capture is sent to the server that will look into it, and it will see if there's any kind of anomaly, for which we change the connection. And meanwhile, we explained the algorithm we used to model it. The starting idea was to use an anomaly detection algorithm that would be based on intensity. But as discussed with the users, because of memory use, we were recommended to use Gaussian mix algorithm. We decided to change, and so that you understand what we've done, in order to choose the number of Gaussian components, we've swept 1 to 10 components, we scanned 1 to 10 components, and then we've minimized it. And this is the number of components we're keeping. Let's see if it connects. We've tried with a small setup, with a limited setup, we found changes in the behavior. This is Grafana. And this is a short dashboard where you see up there the traffic that we get from the sniffer. And well, it's not too complicated, but down there, that's what's interesting. That's the behavior of our network. What we're measuring here is how weird the data we get from the network are, using the DMM model. And there you see, for example, for a value that is 0 here, this would be the regular behavior. And with an increase like this percentage, how much is it? This is 30%, right? We thought that from 30%, a change in behavior, we will start an alert. And this kind of data we got them through the presentations for which we had the lab, and we've managed to produce this change, this detection, and by downloading Netflix films and doing nothing or doing that, or just scanning with Nmap on the network. And that's all. iSecurity and CyberWatcher. Of course it's not working. As with any demo, this is off. So let's leave our little friend here. Does it work? Doesn't matter. So we stampede out of the room, so. Okay. So we are intelligent security. And we had the monitoring and management of security for SMEs. So this is a service, because that's what it is, with lots of technologies. We were very ambitious. I guess we are the most ambitious team ever since the Avengers, and trying to provide security for people who don't have it. So ever since the Avengers, we are more daring, giving security to people who own a business, but are vulnerable and don't have the resources or the knowledge to face that. And first thing I wanted to say is, these have been 2 heavy days at CyberCamp. We've sweat blood, we had fun, we've met interesting people, and we've seen so many interesting projects. So we were 3 people, and after the hackathon, it's 2 of us. But we had someone who deflected last minute, and there's a new team that we want you to meet. And let's try and see if we can hear me. So Google, talk to security agent. Okay. This is the latest version of Security Agent. Good morning. Tell me who you are. I'm a virtual assistant that uses lateral language to report on the security of your company. I can detect several threats thanks to other components that I set up in your infrastructure, even though right now I'm not very intelligent. I'm ready to incorporate new attack detection techniques and learn fast. Better than my former colleagues, that's for sure. Javi, she's outdone you. Here we have it as well. We have many reports. Okay, this one is going on. So this is a demo. Well, this is state of the art. We wanted to discuss the challenges achieved or the landmarks achieved. It's been 2 days. We were starting from scratch. We learned about new technologies. We've been touching modules here and there in so many repositories, and only 3 people. And in the end, we wanted to divide it into 3 parts, which is the application, that's the front end, the virtual assistant, and then the back end. So how did it all end up? For the mobile app, more or less, we got something that is decent enough. We have an app. We will discuss it later on, but here you have it. Not working. Oh, here it is. On the internet. So we've reached it all, almost everything. You see the alert and devices and users and even alerts from the users.
Then we also had the virtual assistant that we presented now. We've managed for the assistant to be able to answer quite a lot of questions, provide quite a lot of details, and also it's quite interesting that if somebody knows nothing about security, like my parents, for instance, they've got me, they think I know something. So if they have a doubt, they can ask me. Well, people could ask the assistant.
Bueno, respecto al backend, es donde yo más he trabajado.
I've been working with Javi at the back end mostly, working with different technologies because we're quite happy. We've covered most of the components we set out ourselves to do. An infrastructure with different pieces of equipment, communicating with a central server. At the beginning, we were thinking of using Splunk. We then decided to use Elasticsearch at the host side and so on, and a server on Flash working with Elasticsearch, and so that Lucas, our colleague, could then pick up on that for mobile details. So we've covered that as well, or most of that. We also proposed a number of different capacities that we can see up on the screen now. For instance, alerts and logs have been covered. We've also got Kibana to be able to visualize real-time reporting. And then threat hunting and security intelligence for threat detection. We haven't done so much of that. We've covered some modules. We've got the infrastructure for more modules to be included, but we didn't have time to cover all of that. Why? Because we forgot about a basic capacity, that is the infrastructure. We thought, we'll just set it all up on Elasticsearch and Amazon, and that will only take a couple of minutes. Well, it didn't. We were wrong there. So I think we can run the demo now. And I'm first going to show you here the central server, including Elasticsearch. This is where our detection system is running. It's like a small driver with different plugins to detect a number of things. There will be a config file so that this is a little bit more simple, so that collecting information from the servers, alerts will be generated, that will be stored on Elasticsearch and then sent to the smart assistant on the mobile phone. So let me just show you some more or less real examples now on the demo. So for the detection service to work, it just needs to be hidden, and then we can modify the config file, which is not what we're going to do now. Anyway, let's run that. You see the initial modules are working. One for detecting different injections on web applications, for instance, as a very simple module covering the whole range depending on the data, scripting, file traversal, that type of thing. Running for the time that you specify on the config file. We have prepared a web application with a cross-site scripting. It's called Multilay. This is a Firebase and SQL that sends details to Elasticsearch. And then the program I showed you earlier will work with that so that the alert can show. It's quite simple. I can't see it properly. The letter size is too small. So the service is now monitoring everything, parsing the logs and the information on Elasticsearch. So look at that. Let me stop it. Right now it's detected there has been a call on a URL. So it gets the parameters, getting the contents of each parameter, and then it starts comparing up against a set of data. There are metrics that allows it to see similarities and differences between them, and then it gives you the likelihood of it corresponding to the cross-site scripting. And there was the notification alert. Did you see that? It says, hey, there has been a new alert coming to the system. This is the injection detector. Poor Javi has been suffering all the tests on his mobile phone. And in that case, it would be associated to the user who might have been the source of that threat. There's also a dashboard that talks about the general status and then general information for people to read and check up on. Google, can I talk to my security assistant? Sorry, I don't know how I can help you. I'm still learning. Okay, Google. Please tell me, what do you want me to talk about? I want to talk to the security agent. Sorry, I can't help you. Talk to the security agent. Google. Okay then. I'm going to find the last version of the security agent. Tell me the status of the company security. An injection code attack has been detected. What is that? Well, a code injection means an attacker might be trying to compromise your company's security, including unexpected values in some of your web applications. You see? That's how it works. Cyberwatcher, the next team.
Y después de CyberWatcher, que se...
And the following team, just get ready because you'll be coming next, is Cyber Spartans.
Espera que ahora no se ve la pantalla. Se ha quedado. Ya arranco yo.
Bueno, buenas tardes. Parece que tengo.
Good afternoon. There seems to be a slight technical hiccup. Let's hope we can overcome it. We asked the cyber watchers, that's the name of our team, Santi, Javier, and myself, 3 of us. So as soon as it's all ready, we will continue with our presentation.
Y contando que vamos bien de tiempo, ¿eh? ¿Qué queréis? Vale. Ah, sí. Estoy arrancando todo porque se me ha quedado el ordenador un poco pillado de esta.
Very sorry, my laptop seems to have crashed. It was all ready, but I probably waited too long with it on.
Pero igual tengo que compartir. Ya. Es que perdí este ratón. Es que la tengo compartida porque la suelo tener extendida siempre. Ahora veis, ¿no?
Are the screens working? Only the smaller ones? I can't see anything on my laptop. Okay, we can all see now what we're doing. That's something. Apologies and thank you for your patience.
Vale, y la presentación estaba en... ¿Se ve, verdad? Sí, vale. Bueno, nosotros...
Good, now it's finally working. That's right, I corrected it. Yeah, I've done it. Thank you. So, as Miguel Angel said, our name is Cyber Watchers. We wanted to design a platform that we are calling SOP, so that users can be identified for logging purposes or identification purposes on websites, so that there can be a centralized platform and we can use it when logging in or having to identify themselves as users. So, double factor identification.
Bueno, trajimos, vino el día siguiente de llegar nosotros un lector de huellas.
So, we couldn't make the USB to work properly. We had a library that supposedly would do that for us, but our browsers couldn't identify the fingerprint identification for some reason. So what did we do? Use the user credentials, username and password, and then as extra security, sending a PIN number to users so that they first register. Then websites that want to use our platform for users to authenticate would need to register with us as well, and then that would all be matched. So for ID management, we used the ID standard, which we think is the most mature technology at the moment. What have we been doing here? Well, mostly learning how to use the fingerprint detector, as my colleague said. But unfortunately, the internet doesn't seem to know that we have IRU 4000, so that's why we couldn't use it. The authentication service finally will work with an SMS, with the additional security given by the PIN number. And then we had the idea that the CyberCamp teams could take a vote on how they think this authentication might work. Because our platform would get users registering just once, giving their details, whatever we think is necessary, and then the platform through OpenID would give websites information. Well, in some cases, maybe the email address as well, but otherwise very basic information. And the voting application, the idea is that a user would log in. You would have their email address just to make sure that people, that people have voted, or they don't vote twice, or that they don't vote on behalf of somebody else. As I said, because the PIN code will be sent by SMS, that will be added security. I think we're going to see this better here on this diagram. This is a flow diagram, call it what you will. You can see there the three stakeholders: users with their PC, the SSOP platform, that's us, and then the voting platform, that would be the third-party system. So the CyberCamp website, in this case, would have to register as client with us as the SSOP platform. Users would also have to register with us at the platform. And then when users start their session, then the cyber voting website sends the logging to our platform, and if the user name and password are correct, we will send the text message with the PIN code, and that's when the platform could say, right, authentication is correct, and let it through. Or we've also studied situations where the website could even keep, as I said earlier, the user's email address and use that as added security and control. We didn't have time for the registration. Well, with Django, we did cover a little bit of that. We have got as far as the token point there, so that access could not be doubled or repeated. So what would happen next? Well, the user would vote. Shall I run the demo next? Well, just a couple of comments. One of the advantages that the SSOP platform offers, the real innovations, are what? Well, avoiding data redundancy. You don't need to have credentials stored at different databases. We think that's really positive. The disadvantage is that the system is centralized, so if it crashes, everything goes or is halted. That's why security has to be super tops for storage to really, really not be vulnerable. What else? Originally, we wanted to implement biometrics as an added element. We thought and finally came up with other possibilities for future improvements. For instance, parental control. Apart from your mobile phone number, you could have somebody else's phone number. For instance, in the case of minors or youngsters with, for instance, a betting addiction or gaming addiction, well, there might be some limitations for certain individuals to be defined. So this is our standard Bootstrap template. Here we have the teams to be voted. And this is the site on 8001, just as an example website. This is the admin button to access Django itself. So when starting your session, OpenID means that the website 8000 would come on, and this is where we validate with our username and password. That means the user would know that the cyber voting application is going to ask for his or her ID. That's because of the token, right? Let's accept that. Then the second token, and apologies for the design because it's not very pretty. So, my colleague's mobile phone has been sent the PIN code. That's right, I've got it here. All I have to do now is, okay, let me tell you, 667175. That's the code. Sorry, 67175. 66. Sorry, wow, let's take advantage of this. I'm going to enter it wrong. I'm going to get it wrong. And that's with a random keypad, by the way. Next one, 148314. That's the next one I was sent just now. So that one's correct. I entered it correctly this time. Something went wrong. What was it? I lost my token because I entered it wrong first time round, or I took too long. Must have been something like that. Let me just try and do it again just quickly. Sometimes the token seems to go missing. Can you give me the new number? 4555. Sorry, 455596. Right. You see, there's the token. We had huge problems with integrating with OpenID, use USB, all sorts, believe me. But we now have the token, and the voting website could then register access, the vote, and then CSR session. Oh, sorry, the closing session button doesn't exist yet. We'd had no time to do that. What would we like to do in the future? Well, adding biometrics, fingerprint authentication, for instance, improving also the registration process for users and websites, reinforcing the security at the SSOP server, and also use registration of identity for users. Who would like to improve that? Thank you very much for your attention.
Vale, Zion Spartans, el último equipo.
And last but not least, we will now be hearing from the last team, Spartans.
Bueno, nosotros somos Acción Spartans, la herramienta.
So our team, Cyber Spartans, wanted to design water to prevent and protect against the times attacks through a point or scoring system. This is the infrastructure on Docker, storing the logs coming from the machines, the container with Python and the application, and then this area here to save the tables, the auxiliary or ancillary tables. Let me run it because at the moment it's still a little bit slow. And in the meantime, as the Docker compost is working, let me just remind you that one of those is going to work as an attacker. The other two will be sending info to Elasticsearch. The demo is too long, and because it's playing in the background, we will have to skip some pieces. This is the V1 machine, sending requests and having access on the other two virtual machines. Later on, from V1, we will see that V2 works with the RP tables. You can see there are no written rules at the moment. That means we can still have access. And in the meantime, the rest of the infrastructure is getting ready to run. So Elastic is going to pick up on all the elements. And this is what we need for the application to use later. This is the window with the indices at the top, coming from the two virtual machines with the file bits. At the bottom, we have the containers running for the infrastructure to be maintained. As logs are sent, you see that at the top it says that 64 documents have been covered. And now the Mongo table here, just to show you how the scores are stored. At the moment is at 15, and no actions will start until it goes over 100. So, what have we managed to cover during the competition, during the hackathon? Collecting the logs, then the analytics, and sending that to Mongo for the score to be studied and for actions and decisions to be made. In the background, we have a process. Can we see the whitelist table up on the screen? Right, because analytics first checks if an IP is on the whitelist, and then nothing happens. But if it's not on that whitelist, then we have to check the scoring table and decide which measure should be implemented. And when that happens, well, we've covered the distribution of actions, the IP table, the rules, so that the rules can run on IP tables for that attacker. And then, well, this is something we did wrong, because we've got this particular one on the whitelist, and then it's not going to work. So, which elements did we not have time to cover because of errors we made? For instance, we have not analyzed the logs. We had problems with parsing the logs. The Elastic didn't get the JSONs as it should have done. We couldn't compare with a blacklist. We had to externalize configs, because at the moment technical users are on the headers. That should be improved for the future. We wanted to do re-indexing of the Elastic indices, and we haven't done that. So when we analyze the logs, they're erased. logically in the future, we should have re-indexing of those logs so they're not lost. There should also be some triggers on the Mongo database so that there's banning or debanning where needed. So dear, I made another mistake. I removed one I shouldn't have removed. So now, because I run it twice, then the banning and debanning is not going to work properly. So if the system gets blocked, this is the way to deban.
Y aquí tengo que poner la que he quitado antes porque si no me baneo a mí mismo.
And I have to add the one that I removed before, otherwise I will be banning myself.
Vale, ahora por detrás estará pasando la tarea que se encarga.
On the background, this is the debanning task, checking which ones are banned and which ones go into the whitelist. We need to have the hot or the warm changing of this one, but still we don't have the way of doing it. Since it's on Docker, we can dump the container and go live again, but
Antes de que las desbanee.
before I deban them. Yes, I debaned it too fast. Let me show the clip again. Let me say about the future. Let me talk about the future. We haven't discussed the future yet, but we want to see that the idea is that every machine sends the same file bit, and we have one index on Elasticsearch, and so maybe the queue would be too long. So the idea is for every machine to send the index, and with multiprocessing, we would gather one of the index and then treat them individually. I had banned this one. And from the IP tables in the machines, and we see that the virtual machine 1 IP had been banned several times, and when added to the whitelist, still banned, and then remove them, and when we're back it works. It was a bit too fast and maybe too messy, and that's enough.
Bueno, como ya hemos terminado las presentaciones y
Since we're done with that, we have 13 extra minutes. This is a first. Actually, we got 13 minutes because there's a team missing. I'll check, but I think there's no one from Ablix here. So that you see that we had measured it to the bit. Let me thank you for having stuck to time. When was the time to be over, which is painful on us. But for this hackathon, we thought it would be 3 hours, but because of a larger amount of teams, we had to stick to the time that we had for some time, and we would have liked to give you more time for final presentations where you're risking it all, but it was impossible. So we do whatever you want. We can start with questions here and use all the time, but I think a break would be better so that you clear your heads, and see you back at 6 at the hackathon room, and that's where we'll have the Q&A, right? And ready for sentence. Thank you very much to all of you.